into some specifics?
Yeah, I'll give you some framework, and I'll mention a few keywords so you can look up more. So we use ordinary differential equations. Typically these models, it could be a handful to dozens to hundreds of equations. And let's stick to the smaller ones. So you have some small ordinary differential equations, small number of them, and we fit it to our data. So we're trying to estimate the parameters using some optimization algorithm to do that. Now, we could just do that with each individual by themselves one at a time. And that's called, when we estimate those parameters, they're called fixed effects. That's statistical terminology. That's fixed effects that we're estimating. So parameter 1, parameter 2, all of those are fixed effects that we're estimating. Now, on some of those parameters, we put additional structure. So we assume that the distribution in our population, the subjects that we're looking at, that their distribution follows a certain pattern, like a log normal distribution for a parameter that's bounded below by 0. That's very typical for biological data. So then we impose that distribution on the parameter in the model while we're simultaneously fitting all the patients. And so that's the random effect piece. We don't know who's going to have which value, but we know that they better all fall into a certain distribution. So we impose that structure. And so those two pieces together are the nonlinear mixed effects, fixed plus random. So there's some terminology you could use to look up some more information on that technique.
Thank you.